Today's lesson will be recorded. If you do not want to be in the recording, send me a chat message and I will answer your question that way, just to let you know that it is being recorded for your benefit. Now, today we're starting chapter 3 and we're dealing with force systems. And force systems are groups of forces that act together. There's 3 types of force systems: concurrent, parallel, and non-concurrent. Those are the 3 force systems. Today we will deal with concurrent. Next time and the time after we'll be dealing with parallel and non-concurrent. So these are the 3 force systems. A concurrent force system, it's gonna be hard to write here, but all lines of action intersect at common point. That's a concurrent force system. This one, a parallel force system, all lines of action are parallel. In a non-concurrent, there's no relationship between lines of actions. So today we're going to deal with concurrent. I'm going to show you a real easy way to solve these. The component method, it's called. There's a couple other ways you can do it. One other way they tell you in the book. I would just stick to the component method. I think it's the easiest and most straightforward. And that's what we're going to learn today. So what a concurrent force system? All the lines of actions intersect at a single point. So if we have 3 forces, start fairly easy here. And let's add some degrees. This, make that 30. 40 newtons to 40. We'll make this, I don't know, 50 newtons. And they're not drawn to scale very well. We'll make this 20 newtons. And they're parallel, or vertical and horizontal. So we have 3 forces acting on the system. Let's give them names. This will be A. This one here will be B, and this one here will be C. So we have 3 forces, A, B, and C. And our goal in all of these problems is to find the resultant, exclamation point, because it's so exciting. We want to find the resultant in all of these problems. So to do that, what we do is we use what we call the component method. So we break, first thing we want to do, step 1, break into components. So any force that you see that's 2-dimensional needs to be broken into components. So that gives us AX, which is 40 cosine 30, and AY, which is 40 sine of 30. So those are our components that we need. So we have BX, we have CY, AX, and AY. Step 1. Step 2. Sorry, I only got so much room to work with here. I got to erase all the time. Let me move this over a little. I'll shrink it down a little bit too. Got a little carried away with my drawing. So step 2 is to create a chart so we can add up our components. And this is the biggest challenge for me, is to draw this with this pencil. And it's the vertical lines that get me. That's pretty good there. So we have 3 forces, A, B, and C. We got our resultant force. We're going to have our X components here in newtons and our Y components in this column in newtons. And now we go back over to our chart. This is step 2. Step 2, make chart to add components. So over here in the x, we'll go to ax first. That's 40 cosine 30. And in the y, we have 40 sine of 30. Bx is negative 20. By is 0. Cx is 0. Cy is negative 50. And now we just add vertically, right? We're just going to take it and add it vertically. We're just going to go right down the columns, add our two columns up. So I'm going to do that here in my calculator. Well, the first one's not good. Oh, that was a bad one, but all right, we'll deal with it. That's 0. 20 minus 20 is 0. No, cosine 30 is not 20. Whew. Pretty excited that didn't turn out to be 0. That would have been sad to start off with that. 14.64 for R, X. And then RY is negative 30. Rx is 14.64, RY is negative 30, right? 20 sine of 30 is 40 sine of 30 is 20 minus 50 is negative 30. So what quadrant is R in? Think to yourself. You don't have to say anything. Just think to yourself, what quadrant is R in? All right, are we done thinking? Now we know the components of R. Rx and Ry. Where's my pen at? And I'm going to move these to the top so I can, once again, do some math underneath. Whoa. And my goal, my third step now is to find R from its components. Find R, step 3, from components. So I go and just like I did before, I draw my force diagram. You can see R is in the third quadrant. R squared equals 14.64 squared plus 30 squared. R is 333.82. And we can find our angle. Tan theta is 30 over 14.64. 63.99 degrees. And then our final step, step 4. Write out R. So R equals 333.82 newtons at an angle in the third quadrant of 63.99 degrees. And there we have it. That is how you find resultants of concurrent force systems.
I have a quick question.
Oh boy,
Why is R in the third quadrant?
Because I screwed up. It should be in the fourth quadrant, huh?
Okay, that makes more sense. Thanks.
Thank you. R should be in the fourth quadrant. Positive X, negative Y. Thank you for letting me know that. There you go. That looks better. Any other questions? You can chat them to me too if you want. All right, let's do another one together. This is all we're doing for the whole period. Concurrent force systems. We're going to start it. I'll draw it big in the beginning. And then I'll move it. Well, let me do a different kind this time. We'll do it off a box. A is Why do I always make 4s? 4.4 newtons. I'm not making a 4. They just don't work with this pen. How about 8.8 newtons? And we'll make it at 40. Oh, goodness. Why am I making 4s? I think I got a brain freeze. 40 degrees. We'll go B is 7.5 newtons. We'll make that at 30 degrees. And C is 6 newtons. So there's our first our concurrent force system. We're going to go through this together again. First thing we want to do here after we draw it is create our chart. In the X, we'll start with A. So this is 8.8 cosine 40. And in the Y, this should be negative. And in the Y, we want to have positive 8.8 sine of 40. B, Bx is positive 7.5 cosine 30. And By is 7.5 sine of 30. Cx is 0. And Cy is negative 6. Now we add up our columns for R. I get negative 0.25 for Rx. Very small. And then for Ry, I got 5.64. That seems wrong. .41, sorry, 3.41. So there I have Rx and Ry. Anybody have any questions on that before I continue with going on to the next step? Anybody? Is that what you got? Does it look right? All right. So we'll go on to the next step, which is to add our column or to find our resultant vector. So we can see we have a negative x and a positive y. And this is going to give us a resultant in the second quadrant, like so. Now we can put them into our formula. I get 3.42 and our angle 85.81 degrees. And we write out our answer. Oops, I forgot the unit. And that's what we do for these problems. How'd we do? Everybody do all right on that? Any questions? Did you like the drawing, the new typing? It's a little easier to read. Hopefully. All right, a lot of thumbs up. So good. Now's your turn. I can do them all day. Man, this is so nice to look at with those typed out clear numbers. Let's try. Three angles. I don't even know what number that isn't right there. I don't want to do that. I don't want that angle. Let's do 40 degrees. All right, try that out. Try that at your seats. All right, let's take a look at what I got. Back to my whiteboard. Unpause, resume share. Can you see it? Crazy, right? What are the chances I put those numbers in and it comes out to be 0? I just made them up. If it comes up like 5.94 e negative 4, that's 0.000594, which for all intents and purposes is 0, right? You're going to get 0 degrees. Oh, 5 of them. We'll never know where this is going to end up. Only 2 angles though. So let's make this 25 degrees and 37 degrees. So we'll make A equal to 4,000 newtons. B will be 5,000 newtons. C, that looks like 3,200 newtons to me. D is 3,000 newtons. And E is, let's make it 2,500 newtons. Try this one. All right, we're back. I got her up there on the screen for you. How'd we do? Good?
So the 37 degrees only affects B and not A?
Yeah, the 37, yeah, A is a horizontal force.
Oh, okay.
The 37 is between A and B. So yeah, so B is the only one affected by the 37. Anybody else have any questions? Do you have enough time to look at this? Do you want me to get really close to the screen? All right, so here we go. We'll start another one up. I don't see any thing here in the chat. Try one more and then oh boy, let's just do 1, 2, 3, 4. 4 forces. Now I gotta write. When it gets fun. 50 degrees, 30 degrees. A is 70 newtons. B is 50 newtons. C is 30 newtons. And D is 80 newtons. I hope they don't all cancel out. We'll see what happens though. Give it a try. All right, I am going to hide my screen or stop sharing. Pause it. All right, I'm done. Let's see if you're done. How you did? Good. Good. When you get it, we're done. Unless you have other questions you want to stay and ask me. If you got it right, that's good. If anybody wanted to talk about their test or anything, I guess I could have brought that up earlier, but I didn't.